Okay, let's talk about a golf ball and a basketball. It's not magic, it's the law. Okay, so we have a golf ball that's 1/5 the size of a basketball, and I want to roll this golf ball around this basketball until it comes back to the same spot. And I want to know how many times will this golf ball revolve. Okay, so let's get started. Okay, we have a golf ball of radius r is positioned on top of a basketball of radius 5r. So here's our golf ball. It has a radius of r and is at the top of a basketball with a radius of 5 times r. Okay. The golf ball is rolled around the basketball until it returns to the top of the basketball. How many revolutions will the golf ball make? Okay, this is what we're doing. We have this golf ball and we're going to roll it all the way around the basketball. Okay. Notice that there are 2 points moving around the larger circle of the basketball. Okay. There is the contact point between the 2 circles right there, and the center point of the smaller circle right there. Okay. And what we're doing is the golf ball with the radius r and the basketball with the radius of 5r, and we're going to roll this golf ball all the way around the basketball until it comes to the same spot. Okay. And like I said, here we go. This is what's going on. So the spot that the circle that's moving around the basketball is the radius of 5r plus r. Okay. So we have radius of 5r, which is the basketball, plus the radius of r. So the radius of this circle, the dash circle, is 5r plus r. This center will roll completely around to the same spot. Okay, so let's see how we would do that. So what's the circumference of the golf ball? The circumference of the golf ball is 2 pi times r. Okay? And what's the circumference of the basketball plus the golf ball? Well, the basketball plus the golf ball is 2 pi times 5r plus r. 2 pi times 5r plus r. That's going to give us the circumference of this red dotted circle. Okay? And that's equal to 2 pi times 6r is equal to 12 times pi times r. Okay? Now, how many revolutions are we going to make? Well, the revolutions, we got to calculate that. We want the center of the rolling golf ball circumference, right here, that red circle, divided by the golf ball circumference, which is right here, 2 pi times r. Okay? So the center of the golf ball divided by the center of the golf ball circle. Okay? So we got 12 pi times r divided by 2 pi times r. 12 pi times r is the circumference of the red dotted circle. 2 pi times r is the circumference of the golf ball, which is 2 pi times r. And if we divide 2 pi times r into 12 pi times r, we get 6 revolutions. Because the r's cancel and the pi's cancel, and 2 goes into 12 6 times. Okay, let's continue. Most people would think that if they divided the circumference of the golf ball into the circumference of the basketball, this would give them the correct answer. Unfortunately, this approach would result in the wrong answer. Revolutions would be 2 pi times 5r, which is the circumference of the basketball, divided by 2 pi times r, which is the circumference of the golf ball. And if you divide those into each other, the r's cancel and the pi's cancel. pi's cancel. 2 times 5 is 10, and 2 goes into 10 5 times. So the revolutions is equal to 5 times. And what you're saying is, how many times does the circumference of the golf ball go into the circumference of the basketball? 5 times. But that doesn't give you the revolutions around the basketball. What gives you the revolutions around the basketball is how many times the center of the golf ball goes around the basketball. And the center of the golf ball is equal to 5r plus r, which is that red circle. As you can see, rolling the golf ball around the basketball circumference raises the golf ball 1 radius, r. So what's the relationship in rolling one circle about a larger one? Let's see. Okay, so we have our golf ball here, and we have our basketball. And as we know, as the golf ball revolves, the center of this golf ball is rolling around the basketball. So let's calculate that. Our revolutions is equal to 2 pi times x times r plus r. What is this x? X is how much bigger the larger circle radius is than the smaller circle radius, which is the golf ball. So I don't know what I call the golf ball radius r, and the radius of the basketball I'm saying is x times r. It's much bigger. So what that bigger is, I don't know. It's x, because I don't know what it is. So 2 pi times x times r plus r divided by 2 pi times r, which is the circumference of the golf ball. Okay. So if I factor out r, now I have x plus 1, 2 pi times r times x plus 1 divided by 2 pi times r. Well, 2 pi times r divided by 2 pi times r is equal to 1. So then my revolutions is equal to x plus 1. So that means whenever I'm rolling a basketball, a golf ball, or around a basketball, a smaller circle around a larger circle, all I got to do is add how much bigger the golf ball is of the basketball. So if the golf ball is 5 times bigger than r, then it's 5 plus 1, which is 6. Okay, let's go on. Let's see what this does. So, okay, roll a larger circle around a smaller one. Okay. Let's say I wanted to roll a basketball around the golf ball. Okay. Then how would I get my red circle? Well, my red circle would be the radius of the golf ball plus the radius of x times r, which is the basketball. Okay. So I do the same thing I did before. My revolutions is equal to 2 pi times xr plus r divided by 2 pi times xr. Okay, because now what's revolving around the small circle is my basketball, or the larger circle. So since the larger circle is revolving around the smaller circle, I divide it by x times r. Okay, so I divide it by the circumference 2 pi times x times r. And as I factor out r here, I factor out r here, and 2 pi times r cancels, and my revolutions is equal to x plus 1 divided by x, where x is how much bigger the larger circle radius is than the smaller circle radius. Okay. And I did this with some coins just to show you how this works. And these coins are given, the dimensions of these coins are given in millimeters. Okay. So 1 inch equals 25.4 millimeters. So 1 penny is approximately 0.748 inches in diameter. Okay. So we want to revolve these coins around each other. Okay. And the way I have this arranged is like this. The purple or the larger coin rolled about a smaller coin. So what's in purple is the numbers that relate to the larger coin rolled about a smaller coin. So a penny being rolled around a dime. The penny is larger than the dime. Here's the dime, and here's the penny. The dime is 17.9 millimeters. The penny is 19 millimeters. The nickel is 21.2 millimeters. The quarter is 24.3 millimeters, and the dollar coin is 26.5 millimeters. So what's in purple is rolling the larger coin about the smaller one. What's in blue, it relates to the smaller coin being rolled about a larger one. Okay. So when the dime is rolled around a penny, the number of revolutions is 2.0615. If you roll a dime about itself, it'll go around twice. It will revolve twice. Okay. So X equals the larger diameter coin divided by the smaller diameter coin. Okay. Same size coin rotates twice. So here we have the same size coin, and I think they have a French coin here, or Canadian. And so I roll it around once, and that's 1 revolution. And I roll it back to the top. Again, that's 2 revolutions. And it's rolled around twice. And as you can see, if I roll a dime around a dime, it rolls about twice. If I roll a penny about a penny, it rolls twice. Nickel about a nickel, quarter about a quarter, dollar coin about a dollar coin. It revolves twice. If I roll a dime around a penny, it will rotate 2.0615 times. If I rotate a dime around a dollar coin, it will revolve 2.4804 times. If I rotate a dollar coin around a dime, it will rotate 1.6755 times. If I rotate a dollar coin around a quarter, it will rotate 1.917 times. That's amazing. Okay. And as I showed you before, the same size coin rotates twice. Okay, here's some video and of the 1982 SAT exam and some coin video.
This video comes from the 1982 SAT exam. This math problem was so hard that no one selected the correct answer. Can you figure it out? In the following figure, circle A has 1/3 the radius of circle B. Circle A rolls around circle B 1 trip back to its starting point. How many times will circle A revolve in total? The answer choices are 3/2, 3, 6, 9/2, and 9. Get out some pencil and paper and see if you can figure it out. Remember, this was on the SAT, so it's a timed exam, and the students would have had to figure it out just using pencil and paper. Here is what the test preparers thought when they made the question. If circle A rolls around a distance of 3 times its circumference, if you do it very carefully, you'll find that circle A will roll around 3 times in total. And that's what they thought the correct answer should be. But let's do a little experiment and see what actually happens if we have circle A rolling around circle B. I've made cardboard cutouts of these circles. If circle A starts at the top and I carefully roll it around circle B, after 1/4 of the distance, circle A is already revolved around 1 time. When we go halfway around circle B, circle A is rolled around a 2nd time. As we continue around, we'll see that by 3/4 of the distance, circle A will roll a 3rd time. And when we complete the trip, as circle A rolls around circle B, when it completes the trip, this will be a 4th time that circle A has rolled around. So the correct answer is 4. And they actually made a mistake. They did not include this as the correct answer. They forgot to take into account that circle A is revolving around circle B, and that would have added 1 more trip around. Let's try and solve this problem in general. Imagine having 2 coins of equal circumference. You would think the answer might be 1, but you see that when the coin rolls around halfway, it's already rolled around 1 time. When it rolls around the remaining distance, it will roll around a 2nd time. So we can solve this problem, and we'll see the correct answer is that circle A will roll around n plus 1 times. The reason is that circle B has n times the circumference, and that'll account for n times that the circle A revolves around itself. But then we will also get 1 more revolution because circle A is also revolving around the center of circle B. So the correct answer is n plus 1. It's a pretty interesting problem. I hope you liked the video. Please subscribe to my channel. I make videos on math and game theory. You can catch me on my blog, Mind Your Decisions, which you can follow on Facebook, Google+, and Patreon. You can also catch me at Presh Talwalkar on social media. And if you like the video, please check out my books. I've provided links in the video description. Thanks for watching.
Okay, and it's just a rolling coin. It's not magic. It's the law. I hope you enjoyed this. And till next time, math is fun.